Hello? 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 I welcome you. I welcome you to this online tutorial on the responses to the items that I left. I believe by now you have them in your books, and if at all you have any challenge regarding anything concerning this chapter on Formulae, Stoichiometry and Mole concept, feel free to reach out to me on those contacts which you have. Now, proceeding with our items, starting with item 1. Oh, my screen is visible. Now, for item 1, Kadeng is a small village where majority of its farmers deal in farming to earn a living and get some food. Of recent, the farmers in the village made some losses and were advised to start applying some nitrogen fertilizers to the soil before cultivation. So Amos has been sent to the agricultural shop to purchase the best fertilizer, which can provide the best yields in the forthcoming season. So some of the samples that are available in the market, we have ammonium sulfate, ammonium phosphate, and urea. So ammonium sulfate has this formula, ammonium phosphate has this formula, and urea has this formula. Then here in the brackets, they have given you the relative atomic masses of the different atoms that make up the given fertilizers. Now the task is to advise Amos on the choice of the product he should go for. So the challenge here, the challenge which is being posed by this item is that farmers are getting losses due to soil lacking, due to deficiency of nitrogen in the soil. So here, to recommend the best choice, we are supposed to determine the percentage composition of nitrogen in each of these 3 fertilizers. And you very well see here that the item is on percentage composition. So we want to determine the percentage composition of nitrogen in ammonium sulfate, nitrogen in ammonium phosphate, and urea, and nitrogen in urea. Then where we get the highest percentage of nitrogen, we shall recommend that as the suitable fertilizer that can supply nitrogen to the soil, or which can be applied to increase nitrogen content in the soil. So for this, for percentage composition is given by mass of an element. If you want to determine the percentage composition of an element within a compound, like in this case, we are determining percentage composition of nitrogen in each of the given compound. So percentage composition is equal to mass of the given element over RFM of the compound, then times 100%. And in this case, there are 3 compounds of consideration. The first compound is ammonium sulfate. Then for ammonium sulfate, we want to determine the percentage of nitrogen in ammonium sulfate. In this case, we shall say percentage of nitrogen for ammonium sulfate is equal to mass of nitrogen over RFM of the compound, which is ammonium sulfate, then times 100%. So we feed in those respective concepts into this formula. So the mass of nitrogen, you have to look at the given compound. Like in this case, we have ammonium sulfate. Now, within ammonium sulfate, there are 2 atoms of nitrogen. Like here, if you can see, there is a bracket here. There is a bracket here. There is another bracket here. Then besides, there is a 2 here. and this 2 multiplies throughout this bracket. So this 2 will affect the nitrogen here. It will also affect the hydrogen, implying that within this formula, there are 2 atoms of nitrogen. That is, if I open brackets. So mass of nitrogen, and each atom of nitrogen, from the information given in the bracket, each atom of nitrogen is, from the information in the bracket, each atom of nitrogen is equal to 14, phosphorus 31, oxygen 16, hydrogen 1, carbon 12, and sulfur 32. So nitrogen is 14. Therefore, in this case, we shall come and say that for the numerator where we have mass of nitrogen, there are 2 atoms of nitrogen. So in this case, we shall have 14, since each nitrogen is equal to 14. So up there is 14 times 2. That is for mass of nitrogen. Each nitrogen is 14, and there are how many? There are 2. Then divide by RFM of ammonium sulfate. Now for RFM of ammonium sulfate, you have to treat these brackets carefully. There is a bracket in front, so we shall open that bracket. Then each nitrogen is 14. 14, then plus hydrogen, capital H is 1 from the information in the bracket, then times, there are 4 of them, times 4. Then after that, there is a bracket that closes. Then after that bracket, if you look at the formula carefully, there is a 2, so we shall multiply by 2. Then plus, there is capital S. From the information in the bracket, capital S is 32. We substitute it, then plus O, capital O is the one that follows, then plus 16, capital O is 16, but there are 4 of them, so we shall write 16, then times 4. Then we multiply the whole of this by 100%, since we want to obtain percentage composition of nitrogen. Therefore, we shall have this information after substituting in the credentials in the formula. I can now take this off. I hope you've noticed how it has been, how the different values have been substituted into the formula. You have to take note of the information given in the bracket, so that you substitute correct relative atomic masses of the different elements. Yeah, and also to open brackets carefully within the given compound. Therefore, in this case, having seen that, in this case, we shall have this nitrogen. There are 2, so the numerator is 14 times 2, then followed by this information down. So up, multiplying up, we obtain 28. Then down, we obtain, if we sum all this up, we obtain 132. Then times 100%. Then calculating that, we obtain 21.2% as the percentage of nitrogen for ammonium sulfate. Next, the next compound is ammonium phosphate. There are 3 compounds of consideration. So in this case, percentage of nitrogen still is equal to mass of nitrogen within the given compound over RFM of the compound ammonium phosphate. So we are supposed to substitute mass of nitrogen within this compound. So when you look at this compound, its formula, if you observe it carefully, there is this bracket here, which opens, and then this bracket which closes. Then besides, there is the 3. So this 3 affects nitrogen, it also affects hydrogen. So implying that if it affects nitrogen, we shall be having 3 atoms of nitrogen within the compound. There are 3 atoms of nitrogen within the compound. And each nitrogen is 14. Each nitrogen is 14. Therefore, for the numerator, we shall have 14 times, since we have 3 atoms of nitrogen. Then for the denominator, now there is this bracket. You have to treat these brackets carefully. So I open the bracket, nitrogen, 14, then plus hydrogen. Each hydrogen is 1, and there are 4 of them, then times 4. Close the bracket as the formula depicts. It says that you close the bracket after feeding in information for hydrogen, then you multiply by 3. This 3 is the one which is here besides, then plus capital P phosphorus 31, then capital O oxygen. There are 4 of them and each is 16. So we shall have 16 times 4. So computing the numerator, 14 times 3, that is 42. Then summing all this information down, where we have the denominator, we obtain 149 as the answer. Then we multiply, computing, we obtain 28.2% as the percentage of nitrogen. Then the next compound is urea. There were 3 of them. Then for urea, still percentage of nitrogen in this case will be mass of nitrogen over RFM of the compound. Urea was 100%. So you have to substitute mass of nitrogen. You look at the given compound, you ask yourself, how many atoms of nitrogen are there? That is, if you are to determine percentage of nitrogen. So if you look at this formula carefully, there's this bracket which opens, then there is also this which closes. Besides, there is a 2. So it implies that this 2 affects each and everything inside here, implying that if it multiplies here where we have nitrogen, there are 2 atoms of nitrogen within the compound. So since there are 2 atoms of nitrogen within the compound, so mass of nitrogen, we shall have 14 times 2, that is for the numerator. Then denominator carbon, each carbon is 12. Then capital O is 16. Then plus, open brackets, we have N, 14. Capital H, there are 2, but each is 1. So 1 times 2, close brackets. Then multiply with the 2, which is here. Then times 100%. So substituting, computing the numerator, 14 times 2, that is 28. Then the denominator will obtain 60 times 100%. Then as a result, we obtain 46.7% as the percentage of nitrogen. So therefore, comparing these percentages, maybe to take you back, for what? The first fertilizer was ammonium sulfate. Ammonium sulfate is here. So we obtained 21.2%. That was the percentage of nitrogen within ammonium sulfate. Then for ammonium phosphate, we have obtained 28.2%. Then for urea, we've obtained 46.7% is here. Therefore, urea, if you compare those 3 percentages, urea has the highest percentage of 46.7%. Therefore, in this case, we shall say that urea is the best choice. Urea is the best choice since it has the highest percentage of nitrogen. And that marks the end of the first item. Allow me to first pause here and continue with item